Dear students, I welcome all of you for today's second session that is on algorithm specification. Hope all of you are familiar with the topics what we have discussed in the previous session that is regarding definition of algorithm, notion of algorithm, and given a problem how to design an algorithm. Yeah. So now in last session, okay, I told you whenever you're given a problem, okay, to solve it, what you will do first, you will go through the problem statement. You will analyze what the problem is actually. I mean, what the problem statement is actually. You're going to become familiar. Once you become familiar with the problem statement, what you will do, you will think of the solution, how you can solve the problem. Okay, each individual will come up with their own solution. So now the solution is in your mind, right? So now what you're going to do, now you want to present your solution to the audience. Okay, so how to present your solution? Okay, so your solution can be presented in the form of an algorithm. So now you have the solution. Okay, now solution need to be presented to the audience. Okay, so how to that solution is nothing but I call it's an algorithm. Okay, so now what are the ways of specifying that algorithm? Okay, so in this session we will have a look at the different ways of presenting my solution, that is an algorithm. Then I'll discuss the main objective, that is recursive algorithm. Okay, followed with further topics. So now coming to the contents. Okay, so these are the following contents what I'm going to discuss in this session. That is, the first one is the algorithm specification. Okay, I said specifying my solution which is in mind to the audience. Got it? For the given problem. And there are three specifications. One is, I think, in your C programming language, while writing a record, okay, on the left side, you might have written some algorithm in the form of in the form such as step one, step two, step three, so and so that we call a natural language. Then, in some for some problems, you might have constructed a flow chart, designed a flow chart, right? Even that's one of the form of an algorithm specification. And the third form is the pseudocode. Pseudo, we know pseudo means it's a false code. I mean, pseudocode is also one of the way of representing an algorithm. But the main difference when I come to flowchart and natural language pseudocode is the pseudocode resembles like a coding. It resembles like a program. Okay, but actually it's not a program. Okay, pseudocode is a mix of programming constructs as well as natural language. Got it? So there are three specifications for algorithm. One is natural language, where we'll make use of English statements, English sentences. Okay, the form of step one, step two, step three. Flowchart, it's a pictorial way of representing an algorithm. Pseudocode is a mix of programming constructs and natural language statements. Okay, so then we'll have a look at pseudocode convention. And pseudocode convention, I mean to say, in my program, okay, I may use make you. There are some rules I need to follow. For example, rules for naming an identifier, rules for how to include a comment, maybe single line comment or multi line comment. Clear? How to begin a block, how to close a block. Similarly, there are some rules we need to follow while representing an algorithm in the form of pseudocode that we are going to discuss. Then we are going to discuss about recursive algorithm. Okay. After once I discuss with the recursive algorithm, I'll just follow with a brief introduction to analysis framework, which analysis is very important. Okay, we'll have a look at that. Okay, then there's something else, measuring an input size, and later we'll have a look at how to evaluate, how to measure the runtime of any algorithm, and we'll have some exercise problems. Now, coming to the first agenda of this session, that is algorithm specification. I said, right, there are three specifications: natural language, pseudocode, flowchart. Natural language, I said, we are writing algorithm in the form of sequence of steps. Step 1, step 2, step 3, so and so. In each step, we are making use of our English sentences. So this is a natural language. Flowchart, it's a pictorial representation of representing an algorithm. Pseudocode, I said, is a mixture of natural language and programming language constructs. Yeah, remember, pseudo means false. Pseudocode means false code, means it resembles like a program, but actually it's not a program. That's why we call it a pseudocode. Now, coming to pseudocode convention, okay. Coming to pseudocode convention, I said in pseudocode because in similar in C or Java, okay, C++, we have we used to use forward slashes, two slashes for single line comment, right? So comment we can make anything that in pseudocode, okay, anything that follows two forward slashes is nothing but a comment, okay. And now, and we know in the next is in programming, we know if there's a compound statements, okay, we enclose those compound statement in a block, right? That block, beginning of block is indicated using an opening curly brace and end is indicated by a closing curly brace. So next, in my program, I use some identifiers, right? Similarly, in pseudocode, we may use an identifier. Okay, the constraint in pseudocode convention is that an identifier should always begin with a letter. Okay, so next we'll make use of some statements, right? In like assignment statement, we can have an expression in our program. Same expressions we can have in our algorithm. Okay, so here when our program we used to make use of equal sign for an assignment, right? For assignment of RHS to LH variable in LHS. Got it. So in pseudocode, what we have the assignment operator is colon followed by equal sign. Okay. And one more thing here, there are two Boolean values. Okay, Boolean we know either 0 or 1. Rather than using 0 or 1, we are making use of keywords true and false. Okay, and like in program, okay, for an array we use square brackets. The same we are going to make use in our pseudocode. Okay, and in pseudocode, also in pseudocode, okay, we can have looping statements like for, while, repeat, until. Okay, so then we can have even a conditional statements like if, then, simple if. Okay, or we can have if, then, else. Clear? Okay. So this is about pseudocode convention. Okay. Now, proceeding further. Okay. So next, like what will have a program? Okay, we will have input and output in our program, right? The same thing we can have input and output in pseudocode also. To give an input to my pseudocode, I'm going to make use of a read statement, and to write something on the screen. Okay, we are going to make use of a write statement. Read acts as an input, write acts as an output. And one thing, remember, in pseudocode, there's only one type of procedure, that is an algorithm. Correct. So the syntax of algorithm is like first I need to make use of for algorithm keyword followed by name I'm going to give for my procedure, and followed by a parenthesis which includes a parameter list. Okay. So just have a look at a simple algorithm. Okay, here I have written the one algorithm. Okay, suppose let me say I've given a problem to find maximum in an array. Okay, so the input to this algorithm is an array. So the input to this problem is that an array. Okay, and the size, how many elements exist in an array. So the as per syntax, making use of algorithm keyword followed by name of my procedure, that is max, and within parenthesis I'm specifying array. A is an array and N is the size of array.
Excuse me, sir.
And 1 second.
Excuse me, sir. Sir, ತುಂಬಾ ಜನಕ್ಕೆ ಲಾಕ್ ಅಂತ ಬರ್ತಾ ಇದೆ.
So you can still I will look at pseudocode. Okay, and the algorithm followed by name of the algorithm within parenthesis input. Then within a block that curly braces. Okay, I have written a code. That code you may feel it resembles like a C, right? So I said the pseudocode. What actual pseudocode is a mix of natural language and like programming language constructs. So now yeah, now we'll have a recursive algorithm. Okay, just here one famous recursive algorithm, that is Tower of Hanoi. Some problem is that I tell you. So recursive, I said, a method or an algorithm, a function calling itself we call as a recursive. Okay, so now we have a look at if you, I think you might have come across this problem, Tower of Hanoi. Okay, what actually this problem means? Okay, in Tower of Hanoi, like you are given three pegs. Okay, we call as a source peg, auxiliary peg, destination peg. And what in on the source peg, okay, there will be some end disk. Okay, the disk with the largest circumference will be at the bottom, and the disk with the smallest circumference will be at the top. Okay, just have a look at this slide. Okay, you can see that there are some 5 disks on the source pair. Okay, now the objective is that in this problem you need to move all these 5 disks to a destination pad such that the disk with the largest circumference will be at the bottom and disk with the smallest circumference will be at the top. Okay, you can make use of some auxiliary pad. Okay, to move in between one disk from among these packs. Okay, so what is the solution is that, so what actually Tower of Hanoi says that Tower of Hanoi says we are implementing it's in a recursive procedure. Recursive procedure means what actual recursive procedure? A function calling itself, invoking itself. Okay, you might have invoked a function with some n. What happens, that function on execution, it invokes itself with some other value for n. Got it? So the recursive approach, what it says that first thing what we need to do, just have a look. Okay, I shown what I in the top n minus 1 disk. Okay, just have a look at figure. Okay, a slide. Okay, at the source. Okay, only the bottommost disk are shown as a rectangle. Okay, a rectangle. The next I have shown like something like a triangle. Okay, this top n minus 1 disk, what I should do now, recursive procedure, what it says, when I invoke with this end disk, okay, what it does first, it invokes itself. But now, while invoking itself, it says move top n minus one disk. Okay, and for this top n minus one disk, what is the destination? It's an auxiliary peg. Okay, and it says that you make use of destination peg as an intermediate auxiliary peg. Got it? Solutions there. First, I need to make use of top n minus one disk. First, I need to move the top n minus one disk to auxiliary peg using destination peg. Got it? So now only one disk will be at a source peg, that is the last disk. And this disk can be moved to the destination peg using a single move. Got it? So next, the remaining top n minus one disk, which were on the auxiliary peg, okay, will be moved to the destination peg using source peg as an intermediate. This is the solution. Got it? If you want, I'll repeat once again. See here, tower of n will be given n disk. N disk are on the source peg. Now I need to move all this n disk to the destination peg using auxiliary peg. Okay. The condition is that always the bottom disk should be with a circumference larger than the topper disk. Got it? So recursive solution, what it says that you move the top n minus one disk to an auxiliary peg. Got it? Using destination peg as intermediate. Then move the bottommost disk to the destination peg. And at the last, you move the n minus one disk which are on the auxiliary peg to the destination peg using source peg as an auxiliary. No, this is just an algorithm. See here. No, look at this algorithm. Okay, tower of n. Okay, as a DSC here, we have n disk. Okay, in this algorithm, just have a look at the syntax prototype. In parentheses, I specified four arguments. The one n is number of disks. X is the source, Y is the auxiliary, and Z is the destination in this case. Okay. So first, what I said, I need to move. I need to invoke itself. Okay. The algorithm. So now I knew what I said. First, n minus one disk need to be moved from X to whom? X to Z. Sorry, here actually X is source, Y is destination, Z is auxiliary. Okay. X is source, Y is destination, Z is auxiliary. So first what I will do, n minus 1 from source X to auxiliary Z. Got it? So then there's one disk on the source peg that I can move in a single move from X to Y. So now n minus 1 disk which are on auxiliary, that is Z, now I will move to destination Y using X as so intermediate. So now coming to analysis framework. Okay, coming to analysis framework, what actually analysis? So reason, you have designed, you are given one problem, you have come up with a solution. Okay, now I need to investigate your algorithm's efficiency. Okay, analysis means I have investigation of designed algorithm's efficiency with respect to two measures, running time and memory space. I mean to say, how much how much time your algorithm requires, okay, to run. I mean, time efficiency of an algorithm indicates how fast an algorithm runs. Space efficiency of an algorithm indicates how much extra space the algorithm requires. Remember, analysis framework is nothing but an investigation of an algorithm's efficiency. I mean, each individual will come up with a solution. Clear? So now I need to investigate whose solution is better or best. For this, I had two parameters: time efficient and space efficiency. Time efficiency means how fast your algorithm runs for the same input. Space efficiency means Of course, your problem might have input and output. Apart from input and output, is there any other intermediate variables I need to make use of? Some extra space. If extra space is used, how much extra space is used? If I want to say your algorithm space efficient, it should use less extra space. Okay. Now, to determine, usually space is very, nowadays it has become very cheap. Okay, memory is very is inexpensive. So what will analysis framework, rather than concentrating on space efficiency, we are going to concentrate much on time efficiency, because time can't be compromised and space is an inexpensive. Okay, so time efficient means, let me tell you, you have written on program, okay, for a given problem. When I run that program on one of your laptop, it may take some X seconds. And the same program, when I run on some other laptop, it may take some X plus seconds. Or on another, in the third laptop, it may take X minus seconds. Okay, but the same program, when I run on 3 different machines with the same input, the time might have varied. So here, to what I said, time, it's a machine dependent. It depends on processor speed, RAM, ROM, everything. Got it? So we are so what we are going to do, we, rather than measuring time efficiency in terms of real time, we are going to make use of one independent metric. Got it? Remember, we are going to make use of independent metric. Okay, and that independent metric, okay, we call, there are 2 types. One is step count, operation count. Why I'm using independent metric? Because the same program, when I run with the same input on different laptops, it shows different time. So I can't because efficient of an algorithm should always be same. Okay, so independent metric I'm going to make is step count, operation count. Step count means here, we need to determine, you see, for the same problem, each might have present their own algorithms. Okay, and I need to look into each algorithm, how many steps are been involved, how many program steps are involved, how many statements are there. Okay, so the number of statements in an algorithm is nothing but we call a step count. Got it? And the algorithm with least number of steps, we call it's going to consume less time. Got it? Step count means number of total steps in a program. What about operation count? Let me say, when we are dealing with some arrays, okay, in arrays what happens, there are the number of steps may vary, because let me say, there are some in program, there are 2 things: fixed part, variable part. Fixed number of statements will always there are some statements which are going to exist fixed number of times. Okay, but when I say looping part, okay, like for loop or while or do while loop, okay, the number of times that loop executes depends on n, right? In the first case, if I say n as 10, it may run 10 times. In the next case, if I give n as 100, it may run 100 times. Okay, got it? So even that we need to consider. There are 2 things: total steps. Okay, it may there are fixed part, variable part. Operation count here. One thing I repeat: step count I told total number of steps in the program. Operation count, what we'll do here, rather than counting all the total number of steps, okay, we are going to concentrate on the most time consuming operation in my algorithm. Okay, what is the basic operation? What is that operation in my algorithm which exists frequently? And we are going to count the number of times that we are going to look at those operations and how many times those operations going to execute. That is an operation count. Got it? So I repeat, step count means all the steps involved in the program. Operation count means here I'm dealing with the most time consuming operation in an algorithm. We consider only the count of that basic operation. For example, I'm determining largest. Okay, the main largest in an array. What you're going to do with the main operation is comparison, right? that comparison is the main operation. We are going to see how many times comparison is going to execute. So yeah, I will look at this example. Okay, step count and operation count. Okay, you see here in this algorithm, I have computed both the step count and operation count. There is first statement is sum initialized to 0. That is one count. Okay, I have written the step count as shown it as 1. So loop for I equal 1 to n. How many times it executes 1 to n plus 1 times? Because first time I equals 1 to n, and at the last I becomes n plus 1 when the condition fails and control comes out of the loop, right? So n plus 1. So body of the loop is going to exit n times. And finally, there's a return statement that is going to exit 1 time. So total number of steps is 2n plus 3. And in this algorithm, the main operation is addition, right? So operation count, what I said, rather than counting all the steps, I am going to concentrate the most time consuming operation, the most frequently executed operation. And your addition is going to exit n times. So I'm concentrating on addition. Got it? Clear with this? In operation count, the frequently executing operation will be considered. Clear with this? So just I will look in step count, I consider each step and how many times each step is going to execute. Whereas in operation count, I consider only the main operation, that is the frequently executing operation. So step count for this algorithm is 2n plus 3, whereas operation count is n. So measuring an input size, okay. So all one thing, what happens? Algorithms. The problem, okay, when I said program runs for longer inputs. Got it? When I say, let me say, in an array, when program for sorting, let me assume, when you give 10 elements, time might be some x seconds. When you give 100 elements, some x plus seconds. When you give 1000 elements, it might take some x plus seconds. Got it? So measuring on input size means here operation count. Okay, we are going to represent in terms of n. I need to decide which input for an algorithm acts as the size. Got it? So we are representing time efficiency, algorithms efficiency, as a function of some parameter n, indicating the algorithm's input size. Okay, repeat, the algorithm's efficiency we represent as a function of some parameter n, indicating the algorithm's input size. I will look at the previous slide. Okay, yes, here I said for this algorithm the size is n. So step count is 2n plus 3. It's nothing but linear function 2n plus 3. Whereas operation count is just an n. It's a function of n, right? So it's a linear. Got it? So how we will represent time efficiency means as a function of some parameter and indicating algorithm's input size. Got it. Units for measuring runtime. I said we are not here. I need to repeat. I am not going to make use of real time. I said because the real time, the same program for same input may vary on different machines. Yeah. So I'm not considering the real time. I'm considering an independent metric, and that independent metric is nothing but step count and operation count we have discussed. Okay. Here, so let me say, I said T of n here, suppose let me say there's one particular operation, let me say OP, and that operation takes COP seconds for execution. Yeah, for one execution on a one machine. And suppose the operation count, the number of times the operation is going to execute C of n. Okay, let me say number of the operation count is 10. And COP, that is time for one operation, is one execution of one time for operation is 1 second. Then the total time is nothing but 1 into 10 is nothing but 10 seconds. Clear? So here the And one more thing, in my operation count, I am considering only the basic operation, the most frequently executing operation. Clear? So some exercise problem. Suppose if I say, how much faster would this algorithm run on a machine that is 10 times faster than the one we have? 10 times faster. Suppose you run algorithm on one machine, it takes X seconds. There is other machine which is 10 times faster than this machine, means it will execute 10 times faster, that is X by 10 seconds. Okay, and one more, I will look at this again. Suppose, let me say, the one algorithm takes quadratic time. Okay, so suppose if I double the size, okay, in the next one, how much time extra time is going to take considering the previous time? Okay, so I mean it is going to take 4 times. This I'm going to explain you as time is expiring. I'm going to consider this problem once again in the next session, and we'll continue with further topics. Thank you.